My name's Alan Hart, and in today's video I'm going to talk about central heating. I'm going to talk about one pipe systems. I'm going to talk about two pipe systems. I've got a two pipe system over that side. I'm also going to show you some underfloor heating systems. I'm going to show you some S-plan and Y-plan and just try and give you a brief overview of central heating and central heating design. So let's have a look now. If you've got any questions, please ask them in the comments below as we're going on through this video. Don't wait till the end because you might forget. All right, let's have a look now. Central heating systems explained. On the right hand side here, we have a Y-plan system, and we'll go into that in more detail shortly. And on the left, we've got an S-plan system, and this one has two zone valves. Sometimes you might have an S-plan plus system, and on that system you'd have maybe 3 zone valves, or you could even have more zone valves. And again, we'll go into that in a bit more detail shortly. We could have a one pipe system. This system here is a one pipe central heating system, and if we see there, we've got one pipe. And again, we'll go into that in a bit more detail shortly. We could have a two pipe heating system. So this is a standard heating system that you would normally see in a property. And then you could also have underfloor heating. So you could have a central heating system that's got underfloor heating. And again, we'll go into this in a bit more detail shortly. So this is a two pipe heating system. There's lots and lots of different types of heating systems and ways that you would control a heating system, but the main system we would use is a two pipe heating system. And what that would be, you would have a floor. Now this floor could be in different materials. This is in MLCP pipe, it could be in copper, and it could also be in standard plastic pipe. This pipe into the radiator here, this is the floor, and out of the radiator we've got a return pipe. So this flow comes from the central heating boiler, and the return goes back to the central heating boiler. So what I'll do now, I'll zoom in and I'll show you this in a bit more detail. So if we look at a two pipe system, we can see the flow there and the flow on this one, and it comes off a T and then it goes down. That would go back to the boiler, or it might go to downstairs if this was upstairs. And then we can see the return again is separate to the floor, and it goes down and it tees in on the return of the other radiators, and again that would go back downstairs or to some other radiators. In this particular case, I got the apprentices to pipe this up, and I got them to pipe it in different materials just to give them a bit of experience. So they've got a bit of experience in soldering, and they've got some experience with press fit on copper, and then speed fit, which is push fit, and then they've got some experience with MLCP pipe as well. So that's your two pipe heating system, and that's your different materials that you could use to pipe it up. What we'll do now, we'll have a look at a one pipe heating system, and we'll see how it compares with a two pipe system. If you've got any questions on the two pipe heating system, please ask them in the comments below. And now if we have a look at a one pipe system, if you were looking at a one pipe system, so pipes come up through floorboards, a one pipe system, you could easily mistake that for a two pipe system, but this is what a one pipe system would look like under the floorboards. Sometimes you might see it running around skirtings, especially in bigger properties. But normal domestic, it'll just be underfloor, so it might be a little bit hard to see that it's a one pipe system. Sometimes you might have to lift the floorboard up just to have a quick look, and what you'd be looking for, you'd be looking if it's got a T, and if that T connects into the other radiator on the other side. I'll just zoom in and just show you that there. So if it connects in on the other side, so we know there the flow and the return are both connected together. So with a one pipe system, you would still have like a flow and a return that would come out of the boiler, but that flow and return would just link together. So it would just come out of the boiler, go around the heating circuit, and then back to the boiler. And off that one pipe that goes round, you would then have your radiators, and there'd be a pipe like this. So what I'll do now, I'll zoom into this and I'll show you a bit more detail on a one pipe system. On this one pipe system, we've got a flow and we've got a return here, and as we see the pipes, it goes up, goes into radiator, goes into next radiator, and imagine this now being under floorboards, and you wouldn't notice and you wouldn't know that we're a one pipe. And if we see this pipe here now, this pipe continues, it don't break, it doesn't stop, and it goes all the way around, and again it just continues, and that might go up on a wall somewhere in edge of house, and then it'll go all the way around with all the rads teeing off it like this, and then it'd go back down, and it'd go back down to rest the heating circuit, the boiler. What's important with a one pipe system, I'll just turn this round. What's important with a one pipe system is if you move a radiator or you alter part of the system, you need to make sure that you keep this circuit in place. So that rather than extend off the circuit, what you really need to do is actually extend the circuit, if that makes sense. So what I mean is, say for instance this radiator's here and you want to move it over there on that wall, rather than just take it off this T here and off this T here, what you really need to do is cut this bit of pipework out, cut this bit of pipework out, and extend the pipework and continue the loop, and that way the heating will still work, hopefully as good as it did before. The pluses and minuses with a one pipe and a two pipe is a one pipe, well, a two pipe say, the pump is forced to go in, the flow of water is forced by the pump to go into the radiator and round the radiator. With a one pipe system, the pump could just pump directly past, and it's only working like on heat transfer up into the radiator. So one pipe systems, sometimes they work really well, but they're not normally as good. Not normally as good as a two pipe system really. So yeah, if you've got any questions on one pipe systems, please ask them in the comments below. I did do a video on one pipe systems, so maybe you could search for that as well. Search for one pipe heating systems, and as I said, I did a full video on that. Let's have a look at underfloor heating now. If we have a quick look at underfloor heating, you have a flow, and that comes from your heating system, from your central heating boiler, or whatever your heat source is really, and also you've got a return. And then when you look at the underfloor heating, some people think it looks quite complicated, but it's very, very easy. It's underfloor heating. You've got a pump on here, and then you've got a little temperature gauge on top there. And what's happening here is we've got a pump. This pump is pumping water round here into this part of the manifold, and then down these two heating circuits here, and then it goes round the floor, which I'll show you shortly, and then it comes back on these two pipes here, and these are the return. I'll just show you on the drawing. If we have a look at a drawing, we can see what happens. So let's just see a short circuit there. So if we have a look at the short circuit there, we can see you've got a pipe, and the pipe just goes under the floor, round, and then back down there. So if we go back to manifold, I'll just show you what they would be. On that circuit we just looked at, if you imagine one of these pipes is the floor that goes round, and then this one is the return that comes back into the manifold. With underfloor heating, you do not want the temperature to be too high, so what you have a blending valve, and that reduces the temperature. The temperature on the floor here, that could be 70 or 80 degrees, and you wouldn't want that to go on the underfloor heating, so it blends the temperature down to whatever you set it. I have done lots and lots of videos on underfloor heating, so if you want to know more, please add a comment below or search on my underfloor heating videos. I am trying to rush this video a little bit. I don't want the video to be too long, so that's just a brief look at underfloor heating. As I say, I've got lots and lots of videos on underfloor heating, so if you need to see any more of them, just click on one of them, or if you ask below, and I'll send you a link to one. What we'll do now, we'll have a look at, that's sort of like the basic heating, central heating design, but what we'll do now, we'll look at control. So now we'll look at a bit of control on how you would control different heating circuits, and then after that we'll have a little look at boilers as well, to see different boilers, because we have open vent boilers and sealed system boilers, etc. So yeah, so let's have a look at the controls now. So now we'll look at control and how you would control a heating system. This is a Y-plan system. What I'm going to do is we'll zoom in and I'll show you how this works. This system is a Y-plan heating system, and if we have a look on this, we've got a wiring centre, we've got a room thermostat, and we've got a cylinder thermostat. With a Y-plan, you'd normally expect this valve to be in the airing cupboard upstairs near the cylinder, and then we've also got a time clock. So what happens if we put boost? So now we're asking the hot water to get hot, and at the moment it's not working. So what we need to do, we need to have a look at the cylinder thermostat. If we turn the cylinder thermostat up so it's calling for heat, then we can now see the boiler has come on. So I'll just do that again, turn it back off. So that temperature has been turned down. If we turn the temperature up, that's now asking the boiler to come on. And in this particular valve, this will be the flow coming up from the central heating boiler, and B is the hot water side of it. So that's just moved now, that's opened, so that the flow of water can come up here and then round here, and that will now go round the hot water cylinder. I have done a video on how a hot water cylinder works, so you might be best to have a look at that. But again, if you ask any questions below, I can always send you a link to that video as well. Now, if we wanted the heating on, the heating works more or less the same, but it's got a room thermostat rather than a cylinder thermostat. So if we put boost on for the heating, and again we'd need to turn the room thermostat up. Once we've turned the room thermostat up, this valve in here will move. If it's only asking for central heating, it'll move so it's fully open in the A position. So full flow goes up AB and then down A, and that'll go round your central heating circuit, whether it be a one pipe system or the two pipe system over there. If you had the timer on for both heating and hot water, and the cylinder stat was calling for heat and the room thermostat was also calling for heat, this in here would stay in the middle position, and it would allow the flow from the central heating boiler to come up A and B, and part of the flow would go down the A and part of the flow would go down the B. So if you've got a system that's struggling a little bit, or in the morning it takes a long time to warm up, then it may be if you put your hot water timer at a different setting to the heating, then when you put your heating on, it would get warm quicker. So what I would normally advise customers is to rather have the hot water on 24/7, so never turn it off. It doesn't mean that it's on all the time. It just means that if it drops the temperature a little bit, it'll just top itself up. Or if they don't want to do that, then set the times to a different time to the heating, especially in the morning. And then when you turn your heating on in the morning, the flow, the flow from the system, whether it be from the pump from the boiler or the pump in the airing cupboard, all the heat can go around the heating system, and the heating would get warmer a little bit quicker that way. So that's the overview of the Y plan system. So now what we'll do, we'll have a look at the S plan heating system. The S plan system works in a very similar way to a Y plan system, but you have two valves instead of one valve. Or if it was an S plan plus, you might have 3 valves or 4 or 5 or whatever. And how that would work, you'd have your flow pipe would come up from the boiler, and then it would T. So you'd have a T pipe in it, and one part of it would go to one valve and the other would go to the other valve, and then you may also have another T that would go to a bypass as well. And how this would work, exactly the same way. So if we put these zones on, it's already on there. If we turn the heating up, and then that will start to call for heat. And then what we'll see here, see that light come on, and we'll just see that valve there. That valve's now opened. I don't know if you've just seen there as well, the boiler's come on. So if we turn that back down, that valve will close. And the boiler will go off. And that works exactly the same on the cylinder. So if we want the cylinder, normally you'd have your cylinder on about 60 degrees. Just click that on, and again that light will come on there, and then that boiler light will come on there as well. We'll just wait till that comes on. So that's come on now, and now that's come on as well up top, and this valve has now opened. And again, if we turn this down, that will go back off. This is wireless as well, and so is this. So this is a wireless, it's a wireless cylinder start, so you wouldn't have to get a wire back to the cylinder with that particular control. But yeah, as we're seeing there, that's now gone off. So again, this works exactly the same in. If you're calling for heat, you'd need the stat to be calling for heat as well for your zone valves to work. And again with this, with your hot water and with your heating, if you have them on at different times, then when you want your heating on, it'll get hot quicker. We've covered quite a lot in this video. One last thing I wanted to just say is about system boilers and combis, etc. So this is a combi boiler, and it's a sealed system boiler, so it has a pressure gauge on the front of it, and then for this particular system you top the pressure up. With an old style system you could have an open vent an open vent system, and you might have a header tank up in the loft, and that would fill automatically by itself. So that's sort of like just a quick, well, I say quick, the video's gone on quite a bit, but it's as quick as I can make it without it dragging on too long. So as I say, if you've got any questions, please ask them in the comments below, and I'll try my best to answer the questions. And yeah, if you want to click up here somewhere and subscribe, and I'll add some more videos around this bit here. Yeah, thanks for watching.